Hi, my name is Guillermo Baigorria, and this tutorial is to show you how to use the Geospatial and Temporal weather generator GiST-wg. In this video, I show you how to generate weather data driven by climate change projections. The process of data generation driven by climate change is similar to the one described in the tutorial number 4, data generation. Major difference is that in this case you have to check this box of climate change. What will happen when you use this climate change is you will be using this file. The file is located in the structure of GIST in this new folder called scenarios. Okay, this file is the same that we just showed in GIST. So if you are developing or want to work with different scenarios, okay, different models or different projections, you just have to change to scenario number 2 or 3 or GCM 1, 2, 3, etc. according to your necessities. So the most important is how to generate this file, okay, and how GIST will be used at the time of generating. Let's see inside this file. This is the file. There is a variable definition. Mean is a prefix. You have M, mean, S, standard deviation, T, total, A, shape parameter. For variables, we have maximum temperature, minimum temperature, P for rainfall amount, E for monthly number of rainy days, and R for solar radiation. And as a suffix, the month. We have from 01, January, to December, number 12. Okay? So important as are these messages. MX, that means the mean of maximum temperature, okay, the mean of minimum temperature, and the mean of solar radiation. These values will be added or removed to the climatological value. For example, if you have a global climate model telling you that in this specific region the temperature will increase in 1 degree, okay, so GIST will add this 1 degree, will move the mean of the distribution in 1 degree to all the generated values. Okay. In the case of total precipitation, mean monthly number of rainy days, standard deviation of maximum temperature, minimum temperature, alpha parameter of precipitation, and standard deviation of monthly number of rainy days and solar radiation. Standard deviation of solar radiation, these values will multiply the climatological value. For example, usually we said for this region, a global climate model will say that the precipitation will increase in 20% or will decrease in 30%. Okay, so these values will increase, will multiply the climatological values. Okay, this is very important to take into account. Another important case of GIST is that we are not only working with a mean, we are moving the distribution to the right or to the left by increasing or decreasing, but also we can modify the variability of the distribution. Okay, many times projections say that the distribution will be higher. We have more. The number of extreme events, for example, will increase or decrease. Okay, so we can change also the distribution, not only for the mean, but also the standard deviation. Okay, the size of the distribution. Okay, let's see the file. Each file is a text file, so you can modify with whatever editor you use. In this case, these are our 7 weather stations of our example, and these are 4 characters corresponding to the name of the weather station, and each column, okay, we have 1, 2, 3, 4, 5, 6 spaces to put a number. Okay, each column corresponds to the description of variable we made before. In this case, maximum temperature, mean of maximum temperature in the month of January. Okay, so here in this space we put the delta values, okay, for each weather station according to the projection we'll be using. The same happens for maximum temperature for every month, minimum temperatures, and all the variables that we already have described before, and you can check every time. This is the default value, where we have the multipliers like as 1 and the added values as maximum temperature like 0. Okay, so if we for any chance check the file and we use this file, nothing will happen because we are changing nothing. We are adding 0 and multiplying by 1. Okay, let me show then one file where you can find some of these values. In this case, for the weather station 1978, we will increase in temperatures in 1.11 degrees. Okay, in weather station for the month of February, the temperature will decrease in 0.03, and so on, so on. Okay, so this is the type of file at the end you will have, and with all containing all the delta for all the variables you want to modify. If you want to add one weather station, what you do is just can make a copy and paste, okay, and put the new name of your weather station, for example XXXX, and you can start to modify all these values according to the projections you are using in your model. Okay, the file will read what you are writing and it will apply it internally at the time of generating the data. So when you have the data generation, you proceed exactly like tutorial number 4. You just upload the correlation matrix you are using, and that's all. If you have solar radiation, remember you can check, okay, and you have two options: Bristol-Campbell model for when you don't have values, or GiST when you have values. You can see the new video about solar radiation in GiST. And what is important here is this value also is for the amount allowing extra precipitation, daily values, okay, of extra precipitation. When you generate climate variability, okay, in the past using time series, you don't want generated values larger than the amount registered by historical records. Okay. However, for climate change, you can allow GiST to produce precipitations larger than the extreme values obtained in the historical record. Okay, so according to the user, you are confident allowing 100% extra precipitation of the maximum registered in one weather station. Okay, 200, 500, 1100. So that depends on the users, and the rest is the same. You just can modify all the rest of the information according to tutorial 4, and that's all. Thank you.